Welcome to another Great Car Basic tutorial. This tutorial is focused on the LGT8XM chipset, and today we'll be covering the 12-bit ADC and some serial communications. It's all very simple, but we'll do some recap and then we'll go into the lab. Okay. So, what are we looking at here? We are looking at a whole series of tutorials, big long list. We're covering 6 and 7 today. So what have we got? We got these chips. They are the 32-pin chip there. They come in 20-pin chips, etc. And this is the type of board that you can purchase, and these are readily available on the internet or direct from the supplier, Logic Green Technologies. They look like this. Is the particular one that I'm using. I'm going to call it the green one. And what we're doing, we've added in a series of LEDs through a resistor. We've added in a potentiometer on the ADC, and I've added in a switch. And from that, we can do quite a lot of experimentation. So this is the LGT on a breadboard. I've got it plugged into that breadboard, and if I show you mine, here it is. It's actually very similar. Let me just pull up. There we go. You can see that Chris has produced this, my South African friend, and the only difference here is that I've got the LEDs, as you can see, in the same position. I've moved the potentiometer to here, and we left it here that when I rotate the pot, the LEDs get faster or slower. That's as far as we got, and that was the ADC setting a weight, and we'll come back to that in a moment. The LEDs are on A0 to A3, or that is port C0 to C.3 respectively, and I have a pot on A6 and a switch on A7. So what we're going to do today is we're going to take the input from, this is actually this white cable here that goes to that particular port, and we're going to change that to a 12-bit, and I'm going to prove to you it's a 12-bit value by sending that value eventually to a serial port so we can see it. So we're going to use the 12-volt ADC to set the delay sequence here, the weight between the LED changing, and we're going to set the switch to reverse the flow, and we'll have a look at that. So the potentiometer is a 10K pot, and it's fitted to port A6, and we talk to it as ADC6, and in Great Car Basic you talk to it using ADC6, not the A6 or PE1. It's ADC6, quite an important point. So let's have a look at where we were previously. This is what we're doing at the moment. We've got a bit of program logic, and it might look a bit weird the way it's laid out, and that's for a particular reason that will become obvious. We set the initial state of the LED here, and we're setting it to LED 4 to number 1, and it does a do loop, and that do loop is continuous, and it does a read of the ADC, rotates the LEDs to the right, it does a wait dependent upon the value of the read ADC, it checks the switch, and then it loops around again, and it goes around in this circle forever. And each time it goes through the rotate, it actually moves the LEDs along. And we saw a diagram of how this works before. We set one LED, and then the next time it sets another LED. So, and it carries on forever. So what we're going to do today is we're going to change that. We're going to do a read ADC 12, and because of that, we're going to do some other work with it, and we're going to test if it's to the right or to the left, and then we're going to move the LEDs in a right direction here, or a left direction. We're going to do a wait. We're going to wait to see if the switch is pressed down, and if it's pressed down, we're going to change the direction, and then we're going to loop back up. So we're going to loop around this forever, obviously, read the ADC, as I said, set the direction, rotate left or right, wait, and then check that switch state. So let's go back. Let's go into that straight away, and we'll see what the code is. This is the code that was there before. In recap, I've set the chip here, and I've told it to option explicit, which is define all my variables. I've set some constants up for the LEDs and the switch. Previously, this is the code. I'm so sorry, I can go to the real code. This is where we set up before. Before we, in here, we read the ADC, and this is moving the ADC to the right, rotate to the right. And that's where we were. If I push the hex, and if I push that hex, it will put that down for us. There we go. And that's just programmed it. And if I now rotate that, it gets slower or faster. That's where we left it before. And so what I'm now going to do is go into another demonstration, number 100, and here we go. Same constants at the top, and this time I'm doing a read ADC 12. And it's a bit of logic here, the if statement, if then statement, and if its LED direction is to the right, it will rotate it to the right, else it will rotate it to the left. Very simple. And then because the value that's going to be coming from the ADC, and I put that in a variable called my delay, I'm going to scale that value, whatever value is returned, I'm just going to scale it down so that we can see it on the LED. Otherwise we'll be waiting 4 seconds, and I don't want to be waiting 4 seconds. So it's going to scale it from 1 to 255 depending on the value, scale to a value of 0 to 4095. It's going to do a wait, and then if it checks the switch and I pushed it down, it will change the direction. The code is as simple as that. Read ADC, an if then statement, rotate in one or the two directions, scale, do a delay, check the switch, and do it all again. Let's just encode that up. And here we go. We've now got the LEDs moving in this direction. I'll slow that down slightly. Here we go. So this is a 12-bit ADC, and I'll prove to you that in a moment. But I reassure you that's a 12-bit ADC. And if I push the switch, now it's moving quite slowly. It's now moving in the other direction. There we go. That's moving to the left on the video. Now it's going to the right on the video. Left on the video. Click, click, click. Now to the right. I'm pushing that switch so delicately. So how do we know that's doing an ADC 12? Well, what I'm going to do is I'm actually going to introduce the serial for Great Car Basics. Extremely simple, same code, but all I'm going to do is after my delay, I'm going to put that out on the serial port. So let me just program that up, and I'll show you what's happening to keep it very simple. So what we'll do is we'll actually encode it and create the hex and program it, and then we'll go out and have a look what it's actually doing. So if I look at my desktop here now, I've got a serial terminal, and let me just open that serial terminal up. Here we go. It's saying that the ADC value is set to 4084. Let me just turn that pot full on. 4095, that's a 12-bit value. If I turn it to 0, it's down to 0. Look. And it's doing that quite nicely because I'm rotating that pot. Now, so I'm doing two things here. One, I'm proving to you that that's a 12-bit value by having that on 4095. And I'm also proving to you that it can do serial. So let's have a look how this all works. So it's worthwhile seeing the actual example. So same setup at the top, but I've added in the serial constants, and we have a constant called USART baud rate. I've selected 9600. You could pick 256, whatever speed you want. I've just used a slow speed. We have a couple more about ensuring that the data is transmitted, called USART transmit blocking, and no delay. So it just pushes it all out as fast as practical. The same read ADC here. And then I've said to it, if it's moving in the right direction, put a right-hand chevron out. And if it's a left-hand direction, put the left-hand chevron out. And we can see that on the screen previously. So if we're looking on that terminal, we can see that when I push the button, it moves in the other direction. So that's the left and the right serial. And it's as simple as saying H serial print. Then I've got some string formatting. I've said to it, send a tab out, send some strings out, do some H serial print some other formatted string. These are functions called left pad and string. These are just standard basic commands to format the display so it's always the right length. And then I say do a carriage return line feed on the serial. And that is the same code. It's got the same scale, it's got the same weight and the same direction test. So to set it up in recap, 3 constants needed. You could get away with 2 if you don't care. And what I'm going to do, just to prove it to you, 57600, I'm going to change the baud rate. So if I change the baud rate, should be pretty simple to do. I'm just going to reprogram. There we go, I've reprogrammed it. Back into my serial terminal, change my baud rate in here. 57600. Open the port. Sure enough, we're working again. Look. So if I rotate that back, I'm back to 0. So the beauty of this is it's very simple to set up the ADC on Great Cow Basic, and it's very simple to use serial. So that's what I wanted to show you today. Relatively simple stuff. I've shown you how to use the serial to communicate with the PC terminal. So get out there and enjoy it.